Let us review the various audiometric patterns. Presbyacusis usually affects the higher frequency range. The audiogram shows sounds have to be made louder before they are heard in the higher frequency range. This looks like a ski slope and therefore is called the ski slope hearing loss. This audiogram shows normal hearing at up to 1 kHz and a mild hearing loss in the mid to high frequency range. Depending on the degree of hearing loss, the sound may have to be made louder before they are heard. A right-handed sloping hearing loss, and this usually is the audiometric pattern in all presbyacusis hearing losses. Noise-induced hearing loss. Now here, the loud noise has caused damage to the hearing organ, commonly occurring at 4 kHz. Therefore, if a hearing loss is noise-induced, one would expect the sounds to have been made louder before they are heard at 4 kHz. The frequencies at 4 kHz are generally affected. Noise-induced hearing loss causing a dip at 4 kHz. Symmetric hearing loss, where the hearing loss is roughly the same in both ears. We consider the hearing loss to be symmetrical if the points for each ear occurs within 10 decibels for each other. The red circle shows the threshold for the right ear, red, right, RR, while the blue is for the left ear. When there is a decline in hearing in symmetric hearing loss, it commonly occurs at equal rates in both ears. Asymmetrical hearing loss. Here, the hearing is different on each ear. On the audiogram on the below, the right ear is mostly within normal limits, while the left ear has a mild to moderate hearing loss across the frequencies. When there is no difference between the air and bone conduction, the threshold conduction, it indicates that the hearing loss is due to a problem in the cochlea. And this is called sensorineural hearing loss. No difference between the air and bone conduction threshold. Sensorineural hearing loss. This audiogram shows a gap between the air conduction and the bone conduction. However, the bone conduction thresholds still indicate a hearing loss and they are not within normal limits. This would suggest that there is a problem in both the cochlea and the middle ear, and this is known as a mixed hearing loss. In this audiogram, it shows hearing within normal thresholds along with the levels and frequencies at which speech sounds are made. As the thresholds are above the speech sounds, we know the patient can hear all speech sounds as they are louder than the quietest sound the patient is able to hear. In this audiogram, some of the hearing thresholds are below the levels at which speech sounds are made. This means the individual will be unable to hear the speech sounds above their thresholds and as a result may feel speech sounds muffled or complain that others are mumbling. By aiding these frequencies, we aim to make these speech sounds audible and therefore make it easier for the patient to hear and understand. Women and children's voices tend to be of higher frequency compared to men and thus harder to hear with a high frequency loss. This audiogram also shows the loudness and pitch at which environmental sounds are made. We have the motorbike here, the piano, children crying, tap water, rustle of leaves, birds chirping, 4,000 to 8,000 hertz, heavy-duty trucks, lawnmowers, rifle, aeroplane at the intensity of 90 to 100 decibels, high frequency, low frequency, mid-range,